All right, so let's talk about factoring. So factoring is the opposite of multiplying polynomials. And that means that we are going to have to write stuff as a product. For example, if I look at 4 times 2 equals 8, then 4, for example, would be one of the factors, and 2 would be a factor. So in factoring, we have to write this mess like a product. One of the things you look for is usually common terms. So if you look at 8, 4, and 6, you can probably see that 2 is in common. So this is one way to do it. Just sort of look at the numbers and see if you can find out what they have in common. Don't forget that the variables can be taken out as well. So that's an x cubed, that's an x squared, and that is an x squared. So at most, I can take out 2 x's. So if I write 2x squared, then that will work for every single one of these terms. And the last thing I need to check is the y's. Now I have a y here and a y there, but it's missing over here. So you cannot take a y out. So write that as 2x squared and then times. So now we're to the product part. And then you figure out what you still have left. So 8 divided by 2 is 4. If you had 3 x's and 2 of them were out, then that means you got to have 1 x left, and then you didn't do anything with the y's. So that's the first term. Copy the symbol, so plus 4 divided by 2 is 2. The x squared is completely out, so that's gone, but the y is still there. And then minus, and 6 divided by 2 is 3. The x squared was completely taken out, and we didn't even have a y there, so that's it. So if I were to distribute this back, I should get the original expression. So 2 times 4 is 8x cubed y, so it works on the first, plus 2 times 2 is 4, x squared y. So it seems to be working, okay? Same thing. Doesn't matter how big these exponents are, or how many letters you have, it's exactly the same principle. So let's see, 12, 6, and 36. They have a 6 in common, so I'm going to take the 6 out. 7 here, 4 m's there, and 4 m's there. So I can take 4 m's out altogether. They all have n's, but let's see, they have 2, 2, and 3. So 2 is the most I can take out. And every single one of these has a p. So 1p, 1p, and 3, so I can take out one of them. Let's see what I'm left with. 12 divided by 6 is 2. 7 took 4 away. That leaves me with 3, 2, and they're completely gone, and p is gone. So that's it. And you're at plus. 6 divided by 6 is 1. And that is going to be important. You'll see that here in a second. Okay. M4, you took 4 of them out, so they're gone. The n squared is gone, and the p is gone. So if you don't write this 1, so if you don't write anything there at all, then you might think that you can move on to the next term. Okay? Which you can't. You can't now go work on this negative 36 and say that's a negative 6. So make sure that you write the 1 there. It's important. Okay, copy the symbol. 36 divided by 6 is 6. 4 m's are gone. 3 of these are 2 of those are gone, but it leaves 1 and 3 p's, so that leaves me with a p squared. So that's one way you can factor. Okay, looking for a common term. Another way of factoring, and this is sort of a trick, is to look for things sort of in grouping and by switching. So 4a minus 6. So initially, I'm sorry, I jumped ahead a little bit. So initially when I look at this, 4, 6, and 3, and 2, well, no numbers are in common. That one has an a, that one doesn't have any variables, so it doesn't look like I can just take out one thing. But if you look at this in pairs, so for example, 4 and 6 have a 2 in common, and 4 divided by 2 is 2, and then the a is left, and 6 divided by 2 is 3, plus, and let's see, b and b, so you can take a b out, and that leaves a 3 minus 2a. Now look at these two terms over here, the things in the brackets, 2a minus 3, 3 minus 2a, 2a minus 3, and if I compare that to 3 minus 2a. Let me write them in a different order. Negative 2 plus 3. So if I took a negative out, then I could write this, 3 minus 2a, I can write that as a negative 2a minus 3. So let's do that and see what happens. So this already had 2a minus 3. And then it becomes plus. Then I'm taking this negative out, so it's a negative b, because I still have the b, and then in parentheses 2a minus 3. And then now you can see, hopefully, that actually you have 2a minus 3 is in common. It's common to both of those. Okay, so since it's in common to both of them, you can take it out. You can write 2a minus 3, that's the common factor, and let's see what you're left with. So that's gone. You're left with 2, and then plus a negative b, that's sort of ugly, so let's write that as 2 minus b. So my final answer is going to be 2a minus 3 times 2 minus b. And if you FOIL this out, you will get the expression back. For example, 2a times 2 is 4a. 2a times a negative b minus 2ab minus 6. And a negative times a negative is plus 3b. So do we have that? So there's the 3b. There's the negative 6, negative 2ab, and 4a. So it worked, okay? Alright. Another pattern that you should be familiar with is difference of squares. And a difference means that we subtract, right? And so a difference of squares. So we're subtracting squares. So, for example, x squared minus y squared. That would be a difference of squares. Okay, that pattern occurs a lot. And it comes from the following. If you FOIL this out, so if I distribute this and write this out, I would get x squared plus 5x minus 5x minus 25. The middle terms cancel, so this is actually x squared minus 25. And the reason we call this the difference of squares is because x squared, that's clearly a squared, but where did the 25 come from? Well, that's actually that 5 times that 5. That's a 5 squared. So there you have two squares. One square minus another square. The difference of squares. Okay. If you see that, then that means you can factor things based on that as well. Okay. And I'll try to get back to this thing over here. But x squared minus 25, well, x squared minus 25, well, that started as, up there as x minus 5 times x plus 5. Okay, how about y squared minus 49? So clearly you have a square here. Is there a number that we can square so that you get 49? Well, it's 7. So if you did y minus 7 times y plus 7, it should be y squared minus 49. And just check the middle terms there. If you do y times 7y, that's a positive 7y, and then here minus 7y. So you see that those do cancel. They can get more complicated. For example, 9h squared minus 16b squared. So if this is a pattern of squares, then the 9 comes from 3 squared, and the h squared comes from h squared. So my guess right now is that for the first, and in the second one, 16, the square root of 16 is 4, so 4 squared would be 16, and that's a b. So I'm guessing that this works. So this is like my best guess. Okay. Now if you're not real comfortable with this, so this one then should be plus 4b. If you're not super comfortable, FOIL it out. See what you get. 3 times 3 is 9, so that's 9h squared, plus 3 times 4 is 12. I have 1h and 1b, minus 4 times 3 is 12, 1b and 1h, so let's write that as 1h and 1b, and you can already see cancellation there. And then the last one is minus, and 4 times 4 is 16, and then you get b squared. And they do cancel, so it worked. How about this thing? Well, that looks really ugly right now. So this is a combination of the patterns, the grouping pattern I showed a moment ago, and then there's another pattern here as well. So m squared minus 121 occurs both here and both there. So if I take it out, I get 2x minus 8 left. So I get m squared minus 121, and then I get 2x minus 8. Okay? M squared minus 21, well, 121 I should say, sorry. 121 is 11 squared, so that is m minus 11 and m plus 11. And then 2x minus 8, both 2 and 8 have a 2 in common, so that's actually 2 times x minus 4. So overall, you could write this as the 2. Usually we write the numbers, let me put a bracket there. 2 is usually put in the front, so numbers go all the way to the front, and then after that it's not really a particular order. At least it's not as far as I'm concerned. And so you can just list all of them this way. Okay, and that's a quick start to factoring. Well, sorry, I forgot I was going to go back to here. So what it says here with can be expanded to ax squared minus b squared means that if you were to FOIL that out, a times a is a squared and x squared minus, say we get a negative here, and then you get minus axb, so I'm going to write them in alphabetical order. And then it's plus abx, and then plus times a negative is a negative. So notice that you see that those cancel. So that's what this means, that ax plus b times ax minus b, when you expand it, when you distribute it, ends up as an ax squared minus b squared. And we just applied this we applied that over here. So I guess what we're trying to say here is that you could have a number here. Okay, so for example, a in this case was 9. And b squared here it did include a number. So that, in this case, this was 4. Over here, I guess it's just a 1. So, alright. Hope that helps.